Let's now look at a chi-squared goodness of fit. And we're going to do a simple problem, and to make sure that you understand that this is a generalization of a one sample two-tailed test on proportions. We'll do a simple case, and we'll do it first as a proportions problem with the z, and then as a true full-blown chi-squared goodness of fit problem. So the problem we'll do is as follows, and we'll answer the question: is a coin, a particular coin, unbiased? And unbiased means that the probability of a head and a tail is equal to a half. So we'll have a chi-squared goodness of fit test. In the long run, we're going to use an alpha of 5%. The sample data, let's say that we toss a coin 100 times, and out of 100 tosses, let's say that we get 45 heads. Alright, so the sample proportion of heads is 0.45. Alright, so first we're going to do this as a z-test. Alright, or if you like, proportions. One sample, two tail. Alright, so let's quickly go through this z-test, since we've done many of them up to this point. It's a two-tailed test, so the true proportion of heads is equal to a half. If the coin is going to be unbiased, alright, so if that's true, the coin is unbiased. And alternatively, P not equal to a half, and the coin is biased. As a z-test, the next thing we do is to draw the z-distribution. Okay, it's a two-tailed test. We use the standard alpha of 5%, so we have 2.5% in each tail, and that gives us the most famous z-value of all. Alright, the plus, we'll have plus or minus 1.96 for the critical values. So decision rule. If z-calc is between these critical values of plus and minus 1.96, do not reject the null. And at that point we'll interpret by saying it is possible coin is unbiased. Remember, that's a weak decision, which is interesting in itself, because it means that we can never prove, even with some level of probability, that the coin is unbiased. All we can say is, the best we can say is, it is possible, it is unbiased. Possible is the key word here. Alternatively, now for the rejection region, if z-calc is not between plus and minus 1.96. Then sample value is sufficiently far enough away from the 50%. Alright, and so I'm going to reject the null and accept the alternate. And for the interpretation, it is likely the coin is biased. Next step of calculations, start off with the standard deviation, sigma sub p hat, square root of p times its complement, 1 minus p divided by n, alright, p is a half, 1 minus p then is also a half, divided by the sample size of 100, and that turns out to be 0.05. And then the z-calc for this problem, sample proportion minus the hypothesized proportion divided by the standard deviation, sigma sub p hat, sample proportion, right, the 45 heads out of 100, that's 0.45. Hypothesized value is a half for it to be unbiased, divided by the standard deviation, 0.05, and that's a calculated z-value of -1. Looking back at your diagram, -1 is in the middle, or the midst of your acceptance region, so we cannot reject the null. Alright, so decision. Since z-calc is equal to -1, and since that is between plus and minus 1.96, alright, do not reject the null. And we're forced to make the conclusion it is possible the coin is unbiased. Yeah, the coin is unbiased. The coin is not biased. Possible though. Alright, and that's the problem as a z-test. And now let's look at that